Hey everyone, in this video we are going to look at a demonstration of angular velocity. So angular velocity is when you are making an object rotate along a certain axis, such as X, Y, or Z, some combination of them. And that I thought it'd be kind of interesting to see a bunch of objects rotate in a synchronized manner. And so what came to mind was a bunch of blinds. So you're opening or closing blinds. So the only thing I did ahead of time is I made this 3D model. You do not have to use this model. Sometimes people have asked me to make the models available. You really don't need this specific model. I will mention that I made this in an external 3D modeling program called 3D Builder. It's free to use. It comes with Windows 10. If you don't have it pre-installed, you can download it from the Microsoft Store. And I also want to mention that I saved this in OBJ format. And so when I imported that OBJ file, for whatever reason, those objects are enormous, and so I had to shrink it from the default scale factor of 1 all the way down to 0.05. So I do want to mention that if you're using 3D Builder, you can use whatever you want, and actually for this demonstration, you could just go to Game Object, 3D Object, Cube, flatten the cube, elongate it. That's really all you need. You're just looking for an object that is basically rectangular in nature. I just wanted a little bit of flair to it, so I made one that has a curve to it, and that one end is thinner than the other. So let's take that model and put it into the scene, and we'll zoom in, and you'll see what I mean. It's subtle, but this comes to a point whereas this is more blunt, and so what we'll do is we're just going to rotate so the blunt side is up. And in my testing, somewhere around -110 works out good. And thinking ahead, we'll put this at exactly 1. So it makes for easier math in a few minutes. Now, what we're going to do is we're just going to copy this over and over and over again. So since we're going to copy it, that means we want this row to be at 100% before we copy it. So all the functionality that we want for every blind should be on the first blind. That way it gets copied as well. So two things. A, this needs a rigid body. So rigid body basically allows for the application of physics, at least as far as movement. So gravity, things like that. Not collisions though. Collisions you need to use a collider of some type. So this is really just motion. So add component, physics, and we'll add rigid body. We'll get rid of gravity. Angular drag probably would eventually have an impact, but since this isn't going to rotate very long, it's really not enough to worry about. Okay, so we have a rigid body. Now we need to add a script to give the blinds to control the blinds and basically to access that rigid body. So right-click, create, C#, and we'll call this blinds con, so blinds control. The name doesn't matter as long as there isn't a space in it. So let's click on our blinds object, drag and drop the script, and now we'll open that up. If you're not familiar with using a text editor and writing scripts, this is a remark statement. You can tell by the 2 forward slashes. A lot of different languages have different ways of remarking out a statement. In C#, it's the 2 forward slashes, so you could just delete it. All it's saying is that everything in the start section gets executed just once, and it's when the object gets instantiated. Another remark statement, again, 2 forward slashes. This is simply saying that everything in the update section is done once per frame. So, in the start section, since we want this to happen as soon as it starts, and then in a few minutes we'll add player control, so get component. What component? Well, the rigid body component, the one we just added. Okay, well, what element of the rigid body do we want to affect? We want angular velocity. And since there are 3 axes, it's vector 3. And if I recall correctly, it's 0 on the x, 0 on the y. And this is going to look a little odd if you haven't done a lot of coding, but you can rotate an object 2 different directions on an axis, so positive or negative. So it's going to be a negative. It's also going to rotate very slowly just so you can see that it's rotating the right way. So we'll choose 0.5. And because it's a decimal, you have to drop in a letter F or else it confuses unity, confuses the compiler. So no rotation on X, no rotation on Y, and a very slow negative rotation on Z. This script has already been applied to the object because we dragged it and dropped it here. And here's the rigid body that the script is accessing. So that should be sufficient to make this rotate. And there we go, and it's rotating correctly. So basically at this point, it's just copy and paste because we're going to just make a whole bunch of these. So copy, paste, and I believe I said for my testing that any spacing of 1.5 worked out good. So this one is 1, so 1.5 addition to that is 2.5. And yes, you don't need the letter F in here. You only need that for the C# script. And now just rinse and repeat. Put this one at 4. Put this one at 5.5. If you're going to have lots of instances of an object, you could in C# use an instantiate command, but we're only going to use like 6 or 7 of these. So honestly, it's not worth bothering when there's that few. You can just, for a demonstration like this, I'm really just focusing on the angle of velocity. I'm not really worried about all the other bells and whistles. But yes, you can indeed use an instantiate command and a for loop to make a whole bunch of these. But again, we're not making that many, so there's really no benefit in this case. Okay, now since this object had everything it needed to rotate and was rotating, now that we've copied the object, every one of them should behave in the same manner. Sure enough, they are. Suppose I could have slid that over a little bit. Let's kind of take our camera and just move it over a bit so we don't have to be staring at the edge. There we go. Okay, so we said that we wanted to now adjust this so it's player control. So like maybe someone is in a room, and if they're close enough to the blinds, they press E or whatever to open the blinds, and then they can close the blinds. So what we're going to do, let's use A to open, D to close. So we're using WASD keys, but usually that's left or right. We'll use it for open and close. So that means this is going to go away, but we're not going to delete it, not yet. So in the update section, we're going to look for key input. So if input dot get key, if you notice this get key and get key down, I'll explain that in a minute. And I believe it's a lowercase a. Now what we're going to do is now we'll take this, cut, and paste. 2 reasons why I did that. A, I'm lazy. B, I wanted to reiterate and really demonstrate that I didn't reinvent the wheel here. I just took this functionality and made it conditional. Rather than having it happen when the object is instantiated, it will now only happen if the A key is being pressed. Now, the difference between get key and get key down is really the difference between rapid fire and manual. So get key down is true precisely once, the first frame in which the button is pressed. So if you continue to hold the button and you're using get key down, it will only respond once. Get key is true every single frame that it's being held down. So again, get key is like a rapid fire scenario, whereas get key down would be manual, that you want them to hit the button every single time they want to activate it. So also, I want to mention that in addition to velocity, you can like add force to an object. However, force is cumulative. So velocity, no matter how many times this executes, you're setting the velocity. You're not adding to the velocity. You're saying this is the velocity. So just to be mindful that if you're using the force command, force is cumulative, that every time you say add force, it adds more and more and more. So now this will open it. But here's the problem. If you let go, it's going to keep going because there's nothing here to say what to do if you're not holding the button. So what we'll do, let's do an else. We'll copy this whole thing because we said that we also want to be able to close the blinds. So else, if D is being pressed, then this would be positive rotation. And then else will have no rotation at all. So again, copying and pasting partly because I'm lazy and partly because, again, trying to reinforce that I'm not reinventing the wheel here. So if A is being pressed, do that rotation. Else, if D is being pressed, do that. Else, set it to 0. So in other words, if neither one of these are being pressed, then it should go to 0. So if I didn't make any mistakes, that should just about do it. So let's run this. I'll hold A, it's opening, I let go, it stops. Hold D, it's closing, let go, it stops. Just like that, you now have manually controlled. I'm just rapidly tapping, I don't have to. Because like I said, you can just hold it. So just like that, you have like synchronized objects that are rotating. There's a range of usages for this, but I just wanted to give you the basic demonstration of what you can use angular velocity for. So that's one more statement in your arsenal if you didn't know about it before. I hope this was helpful. If you want to see other examples, please just leave a comment and tell me what you would like to see. And I hope you found this helpful, and I hope you have a good day.